The next thing I want to discuss is what is called a piecewise defined function. A piecewise defined function is a function that is broken up into several different pieces depending upon the area or the domain portions of the function. For example, this function says that when x is less than or equal to -2, this linear equation is the graph of the function. When x is between -2 and 2, this is the graph of the function. And when x is greater than 2, this would give me the graph of the function. So when you're graphing piecewise defined functions, one thing I want to warn you is make sure you're not doing them in pen because you are going to be doing some erasing. So the first thing I want to do is I want to graph the function -3x minus 2. And I'm going to graph it from the methods that we learned from linear equations. That function has a y-intercept of -2, and it has a slope of -3, which means it goes down 3 and 1 to the right, or alternatively, it would go up 3 and 1 to the left. And I am going to grab my straight edge and draw the line through those points. And then I have to ask myself, which portions of that red line are actually when x is less than or equal to -2? Well, x is -2 right here, so this portion of the line is the only section I'm going to keep, so I'm going to erase the rest of the line that I used for construction. The next one says my equation is f of x equals 4 in between -2 and 2. So the line x equals 4 is a horizontal line that goes through 4. So I draw my line, and then I ask myself, okay, it starts at -2, but one key point about this is it does not actually get to -2, so I put a hole there. And it goes all the way over to 2. And I put a hole there. So that's that portion of the piecewise function. And the last part of my function is the equation 2x plus 1 when x is greater than 2. So the graph of 2x plus 1 is a line that has a y-intercept of 1 and a slope of 2, which is up 2 and 1 to the right. So up 2, 1 to the right, up 2, 1 to the right, up 2, 1 to the right, and I can now graph that equation. Now, one key thing I want to point out is, hey, it only starts at 2, but this one also did not have an equal sign, so it also has a hole. So I'm going to go back and check. This needs to be a function so that each x value can only give me one y value. Well, that's obvious on the places where there's only a single line. Here, at -2, x gives me a single y value, which is right here, because there's a hole there. And at 2, it only gives me a single y value. Actually, it gives me no y values because there's a hole in both locations. If I want to know what the domain is of a piecewise function, I just look at what are all of the valid values for x. Well, here, x is less than or equal to -2. So I'm going to just draw this on a number line. So x is everywhere from here to here. Oh, it's between -2 and 2. So I have holes there and there. And x is greater than 2, which would be this on the number line. And if I wanted to look at this, the overall domain of the function would be everywhere except where there are holes continuously on there. So my domain is -infinity going all the way up to 2, unioned with 2 all the way up to infinity.